In 2012, a ship sailed to an island that 3 separate map databases had already confirmed existed. None of those databases had ever actually checked. They had simply copied each other. This is the story of Sandy Island, a phantom that survived on official charts for over a century. Not because the geography was wrong, but because the systems meant to correct it only made the error harder to find. Maps have always harbored ghosts. For centuries, cartographers populated their charts with lands that existed only in rumor, mistranslation, or the deceptive light of marine mirages. Some of these phantom islands, like the elusive High Brazil or the mythical Isle of Demons, persisted in European atlases from the late medieval period well into the 19th century. Far from being isolated errors, these geographic anomalies became permanent fixtures of our recorded world simply because mapmakers valued the safety of tradition over the risk of empty space. Sandy Island belongs to this exact lineage. Its official life began on a 1908 British Admiralty chart, catalogued as sheet S331. Plotted in the Coral Sea between New Caledonia and Australia, the chart featured a small dotted outline with a simple note, Sandy Island, 1876. The entry originated from a sighting reported by the French whaling ship Velocity more than 30 years prior. Though early hydrographers added the cautious abbreviation ED for existence doubt, the warning flag was gradually stripped away as the coordinates were copied into new publications. By the dawn of the 21st century, this 19th century whaling rumor had quietly migrated into global marine databases and digital mapping platforms like Google Earth, remaining there until late 2012. A navigator's report of no land found at a specific coordinate rarely triggered the immediate division of an island. In nautical cartography, the safety of a vessel matters more than speed, meaning the stakes of an incorrect omission far outweigh the inconvenience of a false positive. If a mapmaker erroneously deletes a shoal, a ship might run aground. Hydrographic officers therefore operate under a strict conservative bias, relying on rigorous chain of custody thinking, where continuity is hard to break. When an unverified hazard was reported, cartographers marked it with the label ED, meaning existence doubtful. Inherited chart traditions favored preserving these entries because proving a feature did not exist was far more difficult than plotting a sighting. Disproval required systematic surveys covering a search area several times the original reported error margin. While commercial mapmakers sometimes inserted fictional features as copyright traps to protect their intellectual property, official hydrographic services had no such motives. Their overcaution was driven by liability. To an agency tasked with maritime safety, keeping a persistent ghost on a chart is a minor academic embarrassment, and deleting a hazard that actually exists is a disaster. In the final decade of the 20th century, hydrographic officers began the monumental task of converting mountains of paper charts into digital databases. This shift was intended to modernize marine navigation, but it introduced a systematic blind spot. When paper maps were scanned and converted into machine-readable vector files, the subtle annotations of the past were often flattened. On a traditional paper chart, a dotted line and a tiny hand-written existence doubtful note signaled to a mariner that a feature was based on an unverified sighting. But computer databases require binary structure. During mass digitization, these qualitative warnings were frequently stripped away or buried inside technical metadata fields that consumer software rarely displayed. What was once a tentative pencil mark on a 1908 British Admiralty chart became a permanent coordinate of absolute latitude and longitude, rendered with the same digital weight as any real island. As these databases populated the early internet, they created an illusion of consensus. When Google Earth, maritime GPS units, and scientific research networks all displayed Sandy Island in the middle of the Coral Sea, it appeared to be independent confirmation. In reality, this was a circular loop. Every single one of these modern platforms was drawing from the same digitized master files, which in turn relied on the same paper records inherited from the 19th century. Because the source lineage was hidden beneath layers of modern code, a single whaler's mistake from 1876 was multiplied across dozens of digital products, disguised as verified geographical truth. Inside modern geographic information systems, copied data easily masquerades as new evidence, meaning that 10 different maps showing Sandy Island did not represent 10 sightings, but rather one old error repeated 10 times. To understand how these ghosts find their way onto charts in the first place, we have to look at the sea itself, which has always been an excellent engine of illusion. Instead of representing a single type of mistake, Phantom Islands belong to a diverse family of errors, each with its own distinct origin story. At high latitudes, mariners frequently mistook massive, dirt-encrusted icebergs for uncharted landmasses. In warmer waters, underwater volcanic eruptions can produce vast, floating rafts of palm ice. These porous stone carpets, sometimes stretching for miles and covered in nesting seabirds and marine debris, look remarkably like low-lying sandy islands to a passing vessel, only to slowly break apart and sink months later. Then there are atmospheric illusions. Under specific temperature conditions, the air above the water acts as a lens, creating complex mirages known as fata morgana. These optical illusions can distort distant waves, low clouds, or even flat horizons into the towering cliffs of an apparent coastline, tempting even experienced captains to record coordinates for lands made of nothing but cold air and bent light. And sometimes the island is born not on the water, but on the drafting table, a simple slip of a cartographer's pen. A misread scribble in a logbook or a transposed coordinate can easily transform a real reef into a distant, non-existent duplicate. While satellite imagery and aerial photography can offer clues, they cannot map the ocean floor. Shallow reefs can look identical to open water from space, making direct, physical verification the only reliable test. A vessel must travel to the exact coordinates to measure what lies beneath the surface, using active sonar to distinguish an absent island from a shallow hazard hiding just below the waves. In November 2012, the Australian research vessel Southern Surveyor sailed to these coordinates. The science team, conducting a tectonic study in the Coral Sea, directed their ship to the exact position assigned to Sandy Island, 19 degrees 13 minutes south, 159 degrees 55 minutes east. Where maps had depicted a solid landmass, the ship's multi-beam echo sounders recorded a uniform seabed lying 1,400 meters down. There was no sand, no reef, and no shallow water. This physical evidence overrode a century of copied records. Once the crew's report reached the Australian Hydrographic Service, official maritime charts were corrected, and digitized databases deleted the island that had never been there. The mapped record changed only after physical evidence overruled database consensus. These cartographic ghosts are not evenly distributed across the globe. They cluster in historically undersurveyed waters, particularly the vast expanses of the Southern Ocean and the isolated stretches of the mid-Atlantic. In these remote regions, sparse data historically forced mapmakers to rely on speculative reports, hoping to err on the side of safety. Once a doubtful feature is entered, it begins its path through a long institutional chain. It travels from early chart makers to national hydrographic offices, eventually flowing down to commercial data providers and consumer mapping platforms. For modern cartography and GIS, this structural vulnerability is a persistent challenge. It reveals how easily inherited uncertainty can propagate through linked digital databases, quietly waiting for physical exploration to catch up with the code. Today, our absolute trust has shifted from paper to algorithms, yet we still confuse database consensus with verified reality. In a fully mapped world, digital systems still inherit the cautious ghosts of legacy charts. Subscribe for more analytical journeys into how we map our world.